General process description of an oil export pipeline, 500 kilometers length. 1. Primary pumping station. Function: initial pressurization of crude oil for long-distance transport. Major components: pumps, centrifugal or positive displacement pumps for pressurization. Surge tanks, to manage pressure surges and provide a steady flow. Filtration units, to remove particulates from crude oil. Instrumentation: pressure transmitters, flow meters, temperature sensors, and level sensors. Automation and control: SCADA, supervisory control and data acquisition systems for monitoring and controlling pump operation and pipeline conditions. Electrical systems: power transformers, switchgear, backup generators, and uninterruptible power supplies, UPS. Hard 2. Intermediate pumping stations. Function: boost pressure to overcome friction losses over long distances. Major components: booster pumps, similar to primary pumps but spaced at intervals along the pipeline. Surge protection: surge tanks or pressure relief systems to manage pressure variations. Instrumentation: same as the primary pumping station for monitoring and control. Automation and control: local SCADA systems integrated with the main control center. Electrical systems similar to the primary station, ensuring reliable power supply. 3. Block valve stations. Function: safety and sectional isolation of the pipeline. Major components: block valves, motor-operated or manual valves to isolate sections of the pipeline during maintenance or in case of a leak. Instrumentation: position indicators, pressure transmitters, and leak detection systems. Automation and control: remote operation capability via SCADA, including emergency shutdown ESD systems. NAF4. Oil receiving terminal. Function: final destination for crude oil before further processing or shipping. Major components: receiving facilities, include pig traps for cleaning pigs and tools, and manifold systems. Storage tanks: large tanks for storing crude oil before processing or shipment. Metering systems: accurate flow meters for custody, transfer, and inventory management. Instrumentation: level gauges, pressure and temperature transmitters, flow meters. Automation and control: advanced SCADA systems for comprehensive monitoring and control of all terminal operations. Electrical systems: power distribution systems, backup generators, and UPS. 5. Storage tanks. Function: buffer storage to manage flow variations and ensure continuous supply. Major components: tank types, floating roof tanks for vapor control or fixed roof tanks. Instrumentation: level transmitters, temperature sensors, pressure transmitters, and leak detection systems. Automation and control: tank gauging systems integrated with SCADA for real-time monitoring. Safety systems: fire detection and suppression systems, overfill protection and venting systems. Electrical systems, grounding systems, lightning protection, and power supply for instrumentation. 6. Pipeline. Function: transport of crude oil from the primary pumping station to the oil receiving terminal. Major components: pipeline material, typically carbon steel with corrosion-resistant coatings. Cathodic protection to prevent external corrosion. Insulation in colder regions to prevent wax deposition and maintain flow. Instrumentation: flow meters, pressure and temperature transmitters, leak detection systems. Automation and control: distributed control systems, DCS, for managing flow rates, pressure, and monitoring pipeline integrity. Safety systems: automatic shutdown systems, emergency response systems, and regular maintenance schedules. 7. Mechanical, electrical, and instrumentation elements. Mechanical: valves, check valves, pressure relief valves, and control valves. Piping: mainline piping, bypass lines, and interconnections. Pumps: mainline and booster pumps for maintaining pressure. Filters and separators to ensure crude oil quality and protect equipment. Electrical: power supply, main power lines, backup generators, solar power for remote areas. Switchgear for distribution and control of electrical power. Motor control centers, MCC, for starting, stopping, and controlling pumps and motors. Instrumentation: sensors for pressure, temperature, flow, and level monitoring to convert sensor signals to data for SCADA. Control systems: SCADA and DCS for remote and local control. Safety systems: fire and gas detection, emergency shutdown systems. 8. Automation and control elements. centralized monitoring and control of the entire pipeline operation. DCS, for localized control at pumping stations and terminals. Communication systems, fiber optics, satellite, or microwave for data transmission between remote locations. Cybersecurity, to protect control systems from cyber threats. Data analytics, for predictive maintenance, performance optimization, and incident analysis. Conclusion. The oil export pipeline involves a complex integration of mechanical, electrical, instrumentation, and control systems to ensure the safe, efficient, and reliable transportation of crude oil over long distances. Each component plays a critical role in maintaining the pipeline's integrity and operational performance. Control system philosophy for the oil export pipeline. 1. SCADA system, function, supervisory control and data acquisition for real-time monitoring and control of pipeline operations. Design aspects, architecture, open system architecture integrating various subsystems through standard protocols. Master Control Room MCR, located at the primary pumping station with a backup at the oil receiving terminal. Communication, dedicated fiber optic backbone with redundancy through leased circuits and radio communication. Servers, dual redundant SCADA servers in a hot standby configuration to ensure high availability. Data acquisition, interfaces with field devices, tank farm management systems, and metering skids to acquire data. Displays, graphical displays, alarms, real-time and historical trends, and reports for operator interface. Distributed Control System, DCS. Function, process control and monitoring at various pipeline sections and stations. Design aspects, integration, combines process control and monitoring functions into a single system. Hierarchy, segregated into Safety Network, Process Control Network, PCN, and Supervisory Control Network, SCN. Controllers, distributed controllers tied into a process control network via a fiber optic backbone. HMI, human-machine interface for process control, shutdown operations, and alarm management. Advanced applications, compensation and correction functions, sequence control, and logic functions. 3. Emergency Shutdown System, ESD. Function, ensure safety by initiating shutdowns during abnormal conditions to prevent damage. Design aspects, independence, standalone system with SEAL-certified PLCs, independent of ICS and FGDS systems. Objectives, prevent serious damage to human life and pipeline infrastructure, facilitate isolated shutdowns. Functions, emergency shutdown functions, continuous monitoring of critical process IOs, communication with ICS for secondary actions. Interface, displays status on ICS process graphic displays, maintenance bypasses applied through ICS HMI. 4. Fire and Gas Detection System, FNG, function, detect and respond to fire and gas presence to protect human life and pipeline infrastructure. Design aspects, independence, standalone, fully addressable, redundant system design. Objectives, prevent and protect from serious damages due to confirmed fire and gas presence. Functions, fire and gas monitoring and control, continuous monitoring of detectors, communication with ICS for secondary actions. Interface, fire and gas data displayed on dedicated ICS graphic displays, maintenance bypasses applied through ICS HMI. Number 5. Integrated Control and Safety System, ICSS. Function, integration of control and safety systems for comprehensive management of pipeline operations. Design aspects, system overview, distributed open systems interconnect OSI architecture combining various independent networks. Hierarchy, Safety Network, Process Control Network, Supervisory Control Network, Master Control Network, and Plant Information Network. Functional philosophy, unmanned operations under normal conditions, manned control rooms for monitoring and intervention. Communication, fiber optic backbone network with backup links for data and voice communication. Key control elements and their roles. 1. Safety Network. Function, handle ESD and FNG functionalities with dedicated SIL-certified safety network. Components, Safety Manager Stations, SMS, ESD PLCs, redundant Ethernet links. 2. Process Control Network, PCN, dedicated to process control monitoring and interfacing with other subsystems. Components, RTUs, PLCs, communication links, fiber optic or wireless. 3. Supervisory Control Network (SC function), provide process control window to local station control systems, maintain data flow to master SCADA servers. Components: local SCADA servers, real-time process data flow, master SCADA servers. 4. Master Control Network (MCN) function, single view and control of entire operations receiving real-time process data. Components: SCADA servers, LDS systems, TMS systems, operational console. 5. Plant Information Network (PIN) function, higher management functions such as data warehousing, scheduling, accounting. Components: firewall routers, secure web server for remote access. Control Center and Handover Philosophy. Master Control Room (MCR) located at primary pumping station, monitors overall pipeline operations. Backup Control. Fujairah AMCR as backup, Swayhan IPS for local station control. Handover Protocol. Point of control and handover rules for switching command power between devices and ICSS using request accept and offer accept protocols. Fallback Strategy. Automatic fallback to backup links and control centers in case of communication failures. This comprehensive control system philosophy ensures safe, efficient, and reliable operation of the 500-kilometer oil export pipeline, integrating advanced control, monitoring, and safety systems. Detailed technical specifications for typical SCADA, DCS, ESD, and F&G systems. 1. Supervisory Control and Data Acquisition SCADA system. Example, Rockwell Automation SCADA system. Hardware specifications: servers, dual redundant servers with Intel Xeon processors, 32 GB RAM, and RAID configured storage. Workstations: operator workstations with dual monitors, Intel Core i7 processors, 16 GB RAM and SSD storage. Networking: redundant 10-100-1000 base T Ethernet LAN with fiber optic backbone for long-distance communication. Communication protocols: Modbus TCP/IP, OPC UA, DNP3, IEC 60870-5-104. Software specifications: SCADA software, Rockwell Automation Factory Talk View SE. Operating system: Windows Server 2019 for servers, Windows 10 for operator workstations. Database: SQL Server for data logging and historical archiving. HMI development: Factory Talk View Studio for creating graphical interfaces and control screens. Alarm management: real-time and historical alarm handling with customizable alarm priorities and notifications. Historical data: data logging at 1-second intervals with up to 5 years of historical data storage. Functional capabilities: data acquisition, real-time data collection from field devices and instruments. Visualization: graphical displays, trends, and reports for operator monitoring and control. Control: remote and local control of process parameters, equipment start-stop, and set point adjustments. Alarm management: real-time and historical alarms with acknowledgement, logging, and reporting features. Redundancy: hot standby configuration for servers and communication links to ensure high availability. 2. Distributed Control System, DCS. Example, Honeywell Experian PKS. Hardware specifications: controllers: Honeywell C300 controllers with dual redundant processors and power supplies. I/O modules: redundant I/O modules with HART protocol support for analog and digital signals. Operator stations: high-performance operator workstations with dual monitors and ergonomic design. Networking: redundant Ethernet backbone with fiber optic links for high-speed data transfer. Software specifications: DCS software, Honeywell Experian PKS R500. Operating system for 2019 for server applications, Windows 10 for operator workstations. Configuration tools: Control Builder for configuration of control strategies, loops, and logic. Alarm management: integrated alarm management with real-time and historical data. Advanced control: PID control, advanced regulatory control, ARC, and model predictive control MPC applications. Functional capabilities: process control, monitoring and control of process variables, regulatory control loops, and advanced control strategies. HMI: customizable graphical interfaces for operator interaction with trending and reporting capabilities. Redundancy: dual redundant controllers, power supplies, and communication networks for high availability. Integration: seamless integration with other systems, SCADA, ESD, F&G, through standard communication protocols. Safety. SIL-rated safety functions integrated into the control system for critical process applications. 3. Emergency shutdown system. Example, Siemens Simatic PCS7 Safety Integrated Hardware Specifications, Safety PLCs, Siemens S7400F FH PLCs with SIL-3 certification. I/O modules, Safety I/O modules with redundant configuration for critical signals. Safety relays, redundant safety relays for executing shutdown commands. Networking, redundant Profibus Profinet networks for reliable communication. Software specifications, safety software, Siemens Simatic Safety Matrix for safety logic configuration. Operating system, Windows Server 2019 for safety engineering stations. Safety library, pre-certified safety function blocks for common safety applications. Diagnostic tools, integrated diagnostics for monitoring and troubleshooting safety system components. Functional capabilities, shutdown functions, immediate and safe shutdown of processes in response to hazardous conditions. Safety logic, configurable safety logic with 2 out of 3 voting, interlocks, and permissive conditions. Alarm and event logging, time-stamped logging of safety events and alarms for analysis and reporting. Redundancy, redundant PLCs, power supplies, and communication networks to ensure system availability. Integration, interfaces with DCS and SCADA systems for coordinated control and monitoring. 4. Fire and gas detection system, FFG. Example, Detronix Eagle Quantum Premier. Hardware specifications. Control panels, Detronix EQP control panels with SIL 230 certification. Detectors, infrared and catalytic bead gas detectors, flame detectors, and smoke detectors. Networking, redundant Ethernet or fiber optic networks for robust communication. Power supplies, redundant power supplies with battery backup for continuous operation. Software specifications, F&G software, Detronix S3 graphics configuration software. Operating system, Windows Server 2019 for configuration and monitoring stations. Diagnostic tools, built-in diagnostics for continuous monitoring of detector health and system status. Alarm management, configurable alarm thresholds and priorities for various detector types. Functional capabilities, detection, continuous monitoring of fire and gas hazards with real-time detection and alarming. Alarm handling, immediate activation of audio-visual alarms, shutdown commands, and fire suppression systems. Integration, interfaces with ESD and SCADA systems for coordinated emergency response. Maintenance bypass functionality with authorization and logging features. Redundancy, redundant control panels, power supplies, and communication networks to ensure reliability. Conclusion. The technical specifications for SCADA, DCS, ESD, and F&G systems highlight the integration of hardware and software components to ensure the safe, efficient, and reliable operation of an oil export pipeline. Each system is designed with redundancy, advanced functionality, and seamless integration to support comprehensive control and monitoring throughout the pipeline network.